Hello, we are here for one more lesson of this SprutCAM training course, and the topic for today will be the high performance cycles. So, still in speaking about milling, we have at least three different types of toolpaths that we can point out as high performance cycles. They have different behavior in terms of the tool movement, but I would say that in the end, the purpose of all of these three are to perform very high performance cutting with a very efficient removing of material in different kinds of shapes, pockets, whatever it is. And each one of them can consider different type of details in terms of parameters, but the purpose in the end it is the same. So I will use this part that you can see in our screen, and I will execute a roughing cycle to show you the different possibilities in each one of these three different types of toolpath. So new, I will do a roughing, as I said, roughing waterline. The operation is created, and now going inside the parameters, strategy, I have in this area, machining strategy, three different types. So I have the adaptative mill. I have another one called adaptative, which is similar. I have one something called high performance cutting, and another one deep high performance cutting. So each one of those it's a little different, has specific parameters. So starting with the adaptative mill, you can see an image of the type of behavior we have in this type of toolpath and on the others that we will show. Basically, the main difference, there are minor things, but the main difference has to do first with the percentage of the tool that we can define to make the increment, or the lateral increment, and not in this one. Okay, in the adaptive we have, in the adaptative mill we don't have. In the other types of toolpaths, we have the possibility to create these smoothing parameters for behavior of the tool between increment or lateral increment and on the linkage of the increments. So let us calculate this first one. I will use only, I will create only two levels so that it's more clear to see the result, and do a run. This will take a few seconds to calculate, and you'll see that in the end we get a very smooth toolpath. Let us see what happens. As these is all of them are toolpaths that take a lot of movements, some of them more than others. I will change the color for a red one because red it is a little more visible. And as you can see in each one of the levels, all the radius, the toolpath tries to follow the shape of the part with a lot of radius. In small areas, you have a lot of linkage and successive passes to avoid a high load on the tool. So it is very smooth, and for a roughing waterline toolpath, it is very interesting to do it. I will try to simulate it around here a little so that we can see. I don't want to do this operation by operation. Let me try to initiate this and what is going on. Okay. Let's try to see a little the movement in this type of toolpath. you can see that, okay, first, you've seen this closed area where the tool goes successfully and in not one pass, but in several passes to remove all the material we have. So you don't see any rough or sharp-ended movement. So it is quite interesting to make this kind of toolpath. If we change now in terms of strategy, what we call a high-performance cutting, this is also intended to make a very efficient removing of material, so high-performance cutting. The behavior of the tool is a little different. The percentage of the tool can change also, and we can have these more radius links on the toolpath. Let's try to calculate it and see what it happens. We can reduce a little. Let's try to reduce a little, 50%, because the idea here was not to have so many passes. But as you can see, a little different behavior, okay? And we can try also to simulate it. So let us try to simulate it. Different behavior, even probably if you look firsthand, maybe you think, oh, it's very similar. No, it's not similar, even because you have to consider also in this type of toolpaths a very important topic also, which is if we want to do a climbing, a conventional milling type, or for both, it depends on the tool you have. So this will influence also the quantity of movements and the quantity of lift ups we have in the part, though it's a very important parameter to consider. But in this type of toolpath, we have this type of movement, which we can call the trochoidal movement, which is smooth, but it takes longer to spend in terms of milling time on the machine. Then we have this deep high-performance cutting. This deep high-performance cutting, it is also something that we can use. We have this type of behavior, if you want to consider. This type of toolpath removes large volumes of material with high feed rates. We can have maximal cutting dips, and we can go until the full length of the flute or the insert of the tool. So we can have this very interesting toolpath. And the cutting wides, or the lateral increments, should go from 5% to 30% of the tool diameter. So if you can see here, automatically change to milling type climb. You can see that I have a percentage of the tool 10%. We have also different parameters, different settings here, where we have the roughing radius of 70% of the tool. So a little different from what we had in the previous one. So let us do OK also. Let us do a run to make the calculation, and probably we will see now a little different type of toolpath, as you can see, with much more lines, but with a lot of rounding movements. So this is to have a very high cutting length, but with a minor removal, maximum removal because of the height of the flute, but laterally not very big loads. So let's try to simulate it also. let us reset the block and let us run it. As you can see, this is a little different behavior. I will try to speed up a little this. I think it is visible that it's doing very different motion from the previous one. So each one of these types has different purposes. It depends on the geometry, it depends on the tool you have, it depends also on the machine you have. So you must choose which it is the most suitable for the job you have in your hand. But at least the idea it is to give you this understanding and this knowledge of all of these possibilities we have with SprutCAM. So any questions, any help that you may need about this topic, let us know. As we said many times, you know already our contact, so please use them if you need them.